Just like there's two different types of ways to solve exponential equations, we're going to look at two different ways to solve logarithmic equations. So the first type is log equations, where we're going to use the definition of logs to solve for x. So remember, log base a of x is equal to y if and only if a to the y is equal to x. So the base goes with the other number and it equals what the argument was. How do you know that this is the method that you're going to need to use when you solve log equations? Well, the log equations that will match this were going to be the log equations where every term does not have a log. For example, number 9, notice that on the right-hand side, -3 doesn't have a log. Over here, 1 doesn't have a log on example 10. And then you'll see when we get to the second type, here, every single term has a log or a natural log. So you know that you use this method if every term doesn't have the word log. Well, how do you solve this way? The first thing we need to do is condense down to a single log. So we need to condense. We use our properties of logs to condense down to a single log. Then we're going to use the definition to rewrite as an exponential function. Once we do that, then we're going to solve for x. And then this is very important. We have to check the solutions. We have to check that our solution doesn't make the argument less than or equal to 0. And this all comes about for the domain of logs. Recall, logs look like this. If you have f of x is equal to the log base a of x, well, when you graph this, remember it had a vertical asymptote here at x equals 0, and they looked like this. Well, recall that the domain of these functions was 0 to infinity. So I couldn't be a number less than 0. I can't even be 0. 0 is not included in my domain. So that's why you always have to check that your answers don't make the argument something that's less than or equal to 0. All right, well, let's go ahead and start these. The first one, log base 4 of x is equal to -3. Step 1, condense down to a single log. Well, this is completely condensed down to a single log. There's only one log in front of it. There's nothing multiplied to it. There's no addition that would need the product rule. There's no division that would need the quotient rule. So then it says, all right, we'll use the definition of logs to solve this. So remember how that works. First, I identify what the base is. Well, my base is 4. So 4, and then I switch. This -3 now is the power that 4 is raised to, and my argument goes on the other side. So I end up with 4 to the -3 is equal to x. All that's left is to solve for x. Well, 4 to the -3 is really 1 over 4 cubed, and 1 over 4 cubed is 1 over 64. So for here, x is equal to 1 over 64. So then I need to check. What I need to check is when I plug this 1 over 64 in this x, so if I were to write 1 over 64 in place of that x, is that going to be a number that is less than or equal to 0? No, 1/64 is bigger than 0, so this number checks out, and my answer then is going to be 1 over 64. Let's look at example 10. I have 3 times the log base 8 of x is equal to 1. Step 1, condense down to a single log. Well, let's see if I'm condensing down to a single log. What I need to do is use the power rule and bring that over to the argument. So this becomes the log base 8 of x cubed is equal to 1. I've condensed down to a single log, so now I use the definition of logs to solve this. So my base is 8, and this is 8 to the first power is equal to x cubed. 8 to the first power is equal to x cubed. Well, 8 to the first power is the same as saying 8. And in order to solve this, I need to take the cubed root of both sides to get rid of the cube. So taking the cubed root of both sides, the cubed root of x cubed, those will cancel and you're just left with x. And the cubed root of 8 is equal to 2. Well, we've solved. Now we just have to make sure that this doesn't make our argument a number that's less than or equal to 0. Well, here's the argument. If I were to plug a 2 in here, will that be a number that's less than or equal to 0? No. 2 is bigger than 0, so this checks out, and my answer is x is equal to 2. The next video is going to deal with the second type of log equations.